Okay, so this is the formula for average velocity, which is change in distance over change in time. This is basically saying you go this far in this amount of time, and that's your speed. That's just the definition of speed, because it's like miles per hour, feet per second, so on and so forth. Now, to find instantaneous velocity, it's a little bit more complicated. So basically, here's the average velocity formula expanded. It's gravity, in this case, since a rock is falling from a cliff, times time squared minus gravity times time squared. And this is the final time, and this is the initial time, as it is down here. And it's all over time final minus initial time. This is because your initial time is going to be 0, and your final time is going to be however long you want it to have been falling for to find it out. So in this case, we're using 16 as our value for gravity, and 3 as the time for how, like, the average velocity over from 0 seconds to 3 seconds. So we do this by going 16 times 3, which is the final time, 3 squared. That equals 144 minus 16 times 0, which is the initial time squared, and this equals 0. And this is all over 3. When you divide 144 by 3, you get 48 feet per second. Now, to expand on this, we can find instantaneous velocity. However, the formula is a little bit different. So in this particular situation, we're going to be using h as our final time and our initial time kind of combined. So see, as you can see, we want to find the instantaneous velocity at 3 seconds exactly. Now, to do this, we have to expand these values and this value. And the reason that we only have one value for h is because there is no initial or final time. It's just one value. So basically, you're doing just that one value. So that's just 3 seconds. So to expand on this, it's going to go like this. And this is going to turn out to 16h squared plus 96h plus 144 minus 144 all over h still. And at this point, we could, in theory, plug this into the calculator to find the instantaneous speed. But we want the value of h to be 0. And the reason for that is because we want there to be no difference in the times, because we already have the time up here. Basically, it ends up on the calculator, there's an error at 0 because you can't divide by 0 in this equation. So, to really get what you want, you have to divide out the h from the h and cancel some things out. So we do this by canceling out the h from here and here, and canceling out this because 144 minus 144 is 0. So it ends up just being 16h squared plus 96. Now, since we're plugging in 0 for h, this whole thing is just 16 times 0 squared plus 96. And that's just 96. Now, since the rock is falling downward, it becomes negative 96 feet per second. But anyway, the reason we use limits for this is because in the calculator cannot compute dividing by 0. So it basically just goes up to the value as x, or h, approaches 0. But here we can find the value algebraically. That concludes this section on limits.
Thank you.